Working with some kind of spinner is another example of a non-discrete geometric probability that we can look at. So here I have a spinner that's marked off yellow, red, green, and blue, and the central angles are provided for me. So for example, the red region is 52 degrees. Let's say I want to calculate the probability that if this spinner stops somewhere randomly on the wheel, it's going to land inside the yellow region. Well, what I'm going to do for that is the same thing I've done so far. I'm going to find the number of outcomes that are what I want, divide that by the total number of outcomes, and there's my probability. So there are 140 degrees out of 360 total that are inside the yellow region. So what I want, yellow, 140 degrees out of the total 360 degrees, then provides the probability that I'm going to land inside that region. Now I'll take my calculator, let's do some work with this fraction. This is going to be reduced to 14/36 or 7/18. Divide both by 2, yeah, 7/18. If I can divide each of those by 20. Now I can turn that into a decimal. So divide. Oops, wrong button. So let's see. So dividing 7 by 18 gives me 0.39 or 39%. Well, it's actually 38.888889. Which is going to cause a small amount of error to creep into my overall answer if I do too many of these calculations, because rounding error is a factor. I should, when I'm done, however, if I add all of these probabilities up, should get back to 100% if I wanted to go that far. So again, the probability of it stopping in the yellow circle is 7 out of 18, 0.39, or 39%. I may also ask, what is the probability of it landing in the blue or the red? So probability of blue or red. Now, when the word or is used in probability, that translates to the probabilities added together, provided they cannot happen at the same time. If they can happen at the same time, I have to account for that by subtracting it off. It gets a little harder. The good news for our purposes, we're not going to worry about the case where B and R both happen. We're only going to deal with the case where it's impossible for both to happen at once. Either the spinner stops in blue or it stops in red. It can't stop in both. So, the probability of it stopping on the blue is 60 degrees out of 360. Probability of it stopping in the red, 52 out of 360. Now, you'll notice from the way that I've written this, I could also have written this fraction down. I could combine these into one and have 112 out of 360. That would be the sum of both of those areas. And that also works for carrying us through this. I'm going to skip the reducing the fraction portion and get right to my decimal and my percentage. So 112 divided by 360 puts me at 0.31 or 31%. So about a third of the time it's going to land in either the blue or the red categories. Again, our primary principles fit like this. What do I want? How much can I have? Take their fraction. When I use the word or, I'm adding two probabilities together, provided they are mutually exclusive and both cannot happen at the same time.